Okay, Math 20s, I want to look at Unit 2, Quadratic Equations, and I want to cover off the first lesson here, graphical solutions of quadratic equations. So the first thing I want to just quickly reiterate is by definition, okay, and I see we've got a little typo there, but by definition, a quadratic equation in standard form is 0 equals ax squared plus bx plus c, where a, b, and c are real numbers and a cannot be equal to 0. Now, what does that mean? The reason a cannot be equal to 0 is because if that a term were gone, that would be a function with a degree of 1, which would be a linear function. So that's why we have to have an x squared term in order to have a quadratic equation. Okay, so that's what that definition means. Now, a couple things. If you think back to the first unit, we've been looking at quadratic functions, okay? And a quadratic function is one, if we just pop it down here to these definitions, a quadratic function is one in where we've got a y equals ax squared plus bx plus c. So that's where y is a function of x, okay? That's by definition a quadratic function where we have two variables, an x and a y, okay? So y is a function of x. That's called a quadratic function, okay? When we solve a quadratic equation, okay, we're saying let y equal to 0. Therefore, now we've got what's called a quadratic equation, and we can solve for the single variable x, okay? This is a quadratic equation, okay? Quadratic equation, okay? Whereas this is a quadratic function, okay? The solutions to the quadratic equation, so semantics, there's a few things that we need to understand semantics. When I say that, what do these things mean? We're just talking different words for the same thing. They're synonyms, sort of. So when we solve an equation, we call that the roots of an equation, okay? So the solutions are called the roots of an equation, or the zeros, those are correspond to the zeros of a function, which we found in our first unit. We found the zeros in our graphing calculator. We entered in the function in y equals form, and we went to second function, calculate number 2, the zeros. That meant what was the value of x when y is equal to 0, okay? The zeros of the function, the roots of the equation, and those correspond to the x-intercepts of the graph. So those are all the same answer, if you want to call it, okay? But we call them different things depending on what we're talking about. But they're essentially the same. So a quadratic equation can have 1, 2, or no real solutions or roots for x, which will make the equation equal to 0. So let's have a look. Paper and pencil. How would we do this using the paper and pencil method? I want to solve this equation, okay? It's an equation because it's equal to 0, right? So therefore we're looking for the roots of an equation, okay? We're going to look for the roots of an equation, and we want to use the paper and pencil method. What I'm going to do is I also want to just quickly talk about this x and f of x. So f of x is just a fancy way of calling this y, okay? And in other words, we can say the value of the function when x is -5. F of -5 means the value of my function, okay, which the corresponding function would be y equals x squared plus x minus 12. That would be the corresponding, okay, the corresponding function. Now, if I want to solve f of -5, that means I'm going to sub in -5 for x, okay? So I'm going to sub in -5 for x. So I've got -5 all squared plus -5 minus 12. And I can, of course, solve that. I could do that by hand. I'm going to use my graphing calculator, okay? I'm going to use my TI-83 that I've got, or TI-84 rather, that I've got downloaded. So I'm going to put a -5 squared plus a -5 minus 12. And I get a value of 8. So in my table, I'm going to go back here, and f of -5 is 8. All that is a point, a set of coordinates. That means when x is -5, okay, y is 8. I'm going to plug that in on my graph, or sketch that, I might plot that on my grid here. Unless I've counted wrong, that should be -5, 8. Okay, -5, 8, right there. I'm going to find the next one, f of -4, okay, f of -4. And what would that be? Well, that's -4 squared plus -4 minus 12. I'm going to plug that in my calculator. Now, a little handy dandy trick, okay? If I go down here, we had our 8. If I want to re-enter something and I don't want to type everything in again, I can go to second function enter. And what my calculator does is it just types in what I just had, okay? I'm going to delete the -5, arrow back, delete the -5, enter a 4, and I don't have to retype everything again, okay? Same thing if I push second function enter, it enters what I just had. I'm going to delete, change that to a -3 in anticipation of the next coordinate, okay? Delete, push a -3, and there's my next two answers. 8 was the first one, 0 and -6. So I'm just going to fill that in. That's a 0. This one would be -6, okay? By typing in the -3 squared plus -3 minus 12, okay? And so on. I'm going to do -2, -1, and so on. Why don't you pause the video and you figure out the remainder of the table on your own. Okay, so hopefully you were able to find those coordinates by plugging those into your calculator or solving by hand. And now I've plotted my points. I'm just going to connect those dots and create my parabola. I know that my vertex would go down here somewhere. I'm not exactly sure how low it would go, but I'm just plotting and connecting what I have. And in this unit, we are looking more at the x coordinates. Notice that's what I'm looking for. I'm solving for x. And those are the roots of our equation. So the roots of our equation, the answers here, okay, the roots are equal to -4 and 3. Okay, so this value here is -4, 0, and this value here is 3, 0. So we're basically looking for what is x when y is equal to 0, okay? Which is the whole idea for this unit. The last unit, we looked at the y coordinate of the vertex. What was the maximum? What was the minimum? Okay, it was all about the q value. In this unit, it's going to be about solving for x. Okay, this page here talks a little bit about, or these are sort of a cheat sheet or kind of the steps that we would take to find a max or a min, which we've done in the last unit. Okay, find the y value, okay, when determining the x-intercept, the y-intercept. So the x value would be 0. Okay, how to find zeros of a function or x-intercept. Second trace number 2, the 0, and that's where you would find the left boundary and the right boundary of that x-intercept, which is what this is showing here. Okay, if we envision that left line, this would be that line, vertical I should say, that would be the left, and this would be the right. Okay, and if we do the same thing on the other one, right, if we were to do the same thing on the other one, we would say this would be the left and this would be the right. So we would go through and do that process for both x-intercepts. The other way to do that, which I've mentioned in class, is we can go we can enter, another y2 equals 0, okay? That horizontal, okay? That horizontal line right here, okay? y2 equals 0. And then another way to do that is to say second function calculate number 5, we want those intersection points, okay? We're finding the intersection points, and that's another process that we can use to find the intersection of these two lines between the parabola and the horizontal line there, okay? That's another method. And then the last thing is, of course, how to find any intersecting lines between any two points, and we're going to do that today. So, using our graphing calculator, it says to solve an equation or to determine the roots of an equation, look for the x values that make the left and right sides of the equation equal to each other. Graph one side of the equation in y1 and the other side in y2. That's one method, okay? The other method, method 2, okay, is to find the x values that make the equation equal to 0. Okay, so we're going to start with method 2 here because this is already equal to 0, okay? So what we're going to do is we're going to enter this in our graphing calculator. This is all graphic, okay? We're doing graphing calculator stuff in this lesson. So I'm going to enter this into my graphing calculator as a y1 equation. Okay, so let's just go in and we're going to do that right now. Whoops. Into our TI-84 here. Y equals, and I've got an x squared plus 5x plus 6 Okay, let me just double check that that was what that was, plus 5x plus 6. Yes, it was. And I'm going to go to zoom standard, zoom 6, and there's my graph. Now, this one I can just take my fingers and kind of enlarge that a little bit. I don't think a regular graphing calculator, well, I know you can't do that on a regular graphing calculator, but this one you can. So if I want to find these x-intercepts, I'm going to go to second function, calculate, number 2, the 0, and my calculator says show me a left boundary. So I'm going to scroll with my cursor until I'm left of that x-intercept, and then I push enter. And then it says show me a right boundary. At the top you can see where it says right bound, and I push enter, and right away it hops over to that 0. It says the 0 is negative 2.99996. So I'm just going to round that to the negative 3. Okay. The other dot there, that other x is negative 2.56. That's the round dot that you see on the page. That's not what we're looking for. We're looking for the 0, which is the square. Okay. So if you were using a regular graphing calculator, once you push the right boundary, you have to push enter one more time. Okay. You need a third enter for it to guess. So it's slightly different from this calculator. Okay, those of you in class have seen it on my screen, so depending on your calculator, this is what you would do. But one of our zeros there is negative 3. If I want the other one, I'm going to go second trace again, number 2, the 0. Now I'm already to the left of that point. I'm going to push enter, and I'm going to scroll over. I'm at the right now, and it went from the right point, and my 0 there is negative 2.00004, which is just negative 2. Okay, so I'm going to write that down. So x was equal to negative 3 and x was equal to negative 2. Those are our two answers for that particular question. Another way that I could have done that is I could have gone into y equals, and I could have entered y equals 0, my second equation, okay, the red line there, and I could say where do those two intersect, because the y equals 0 is the equation of the x-axis, and I can choose number 5, and it says go to the left boundary of where those two lines are. I just did that. Go to the right boundary of where those two lines are, and there's their intersection right there at negative 2, 0. Okay, the point there at the bottom of the screen, you can see it says P1 is negative 2, 0. So again, I can do the same thing with the leftmost intersection, enter on the left, enter on the right, and you can see the intersection point 1 there, it says is negative 3, 0. Okay, so that's another method to do these types of questions. Okay, if we look at question D, okay, we're not doing all of these. I would like to do A, D, and then E. Okay, so for question D, what I want to do again, I want to enter this in a y1 format. Okay, so 2x squared minus 5x plus 5. So I'm going to go back into my y equals and clear this out. 2x squared minus 5x plus 5. And I hit graph. And I'm just going to play with my windows a little bit so that I can see that more clearly. If I go from zoom standard, okay, there's a zoom standard. That's what you should see with your regular graphing calculator, or depending on what calculator you've got. Now I want to find the x-intercepts. That's the whole thing. We want to look at where does the graph cross the x-axis. If I look at this, well, if I try finding the x-intercepts, I can see right away that there are none. So what does that look like as an answer? Okay, I'm just going to do a quick sketch here. Okay, and so what that looked like was something like this. And of course, we know that our y-intercept here was 5 because that's our constant. Okay, y-intercept is 5. Okay, there's our c value. And if I do just a quick graph here, it looked something like this. Okay, so our roots of our equation, or the zeros of our function, or the x-intercepts of our graph, well, there are none. Okay, this is our x-axis. So there's no, there's no x-intercepts. Okay, and therefore there's no solution. Okay, that's the answer to this question, is there's literally no solution. Okay, let's look at question E. So question E, the same thing. So I would highly recommend, if you're doing this at home, that you pause the video and make sure you're getting the same graphs and the same solutions as me. So when I do this one, okay, the first thing I want to do is I notice that these are all equal to 0, equal to 0, equal to 0. Okay, so what I want to do for this first one, I want to make this equal to 0 so I can find the zeros of my function. I want to have one function. So I'm going to move over the 5. When I move over a 5, it becomes a negative 5. Now I'm going to simplify my left-hand side. I've got x squared plus 4x minus 8, right? Negative 3 minus 5 is, of course, negative 8. So now again, I'm going to enter this into my calculator as a y1, x squared plus 4x minus 8. Clear out that one, x squared plus 4x minus 8. And I push graph. Okay, and I still want to find my 2x intercepts. I'm going to do that. Second function, calculate the 0. Depending on which way you want to do that, I'm just going to scroll so I can find my cursor. I find the left boundary, push enter, the right boundary, push enter, and right away I've got a negative 5.46. And this question at the very beginning of the example, it said round the roots to the nearest tenth if necessary. So that, of course, means 1 decimal. So negative 5.46, whoops, which of course would be negative 5.5, right? 0.46, negative 5.46 means we round up to negative 5.5. So there's one of our answers, okay? The other one, second calculate, number 2. I'm going to scroll over and do my left bound and my right bound. And again, if you wanted to do the y2 equals 0, that would work as well. There's my left boundary, here's my right boundary, and that intersection is 1.46, which we would round to 1.5. Okay, there's our 2 answers. Now, the other thing I want to do here, I'm going to cross out F. Okay, we're not doing F. I want to quickly do E in another way. I'm going to call this E2. Okay, I'm going to rewrite E as x squared plus 4x minus 3 equals 5. Now, instead of moving everything equal over to one side, okay, we haven't done this yet. We've done all of method 2 so far, okay? A and D and E, we use method 2. What I want to do is I want to try a method 1 approach, which means we're looking at each side. One side is going to be y1 and the other side is going to be y2. And then we're looking at the x values of the intersection points. So let's look at that. How would we enter this in our equation, or sorry, in our calculator? We're going to go y1 and y2. So y1 is x squared plus 4x minus 3, and y2 is 5. So I'm going into I'm going to change this to a minus 3, and y2 is 5. So I graph those 2 lines. Now I've got 2 particular lines, and I want to find the intersection of those 2 lines, and I want to see what my answers are. So instead of choosing number 2, I'm going to choose number 5. I want to find the intersections. Again, my calculator, this one asks for the left boundary. I go left of those 2 points, the point of intersection, and I move right to the point of intersection. And the square dot is my answer. That value is 1.46, 5. I run around my x value to the nearest tenth, so that would be 1.55. So in this case, what we've got here, okay, is we have something like this, okay, and this. Let me just fix that because it was more like this. Okay, it was over the other side, sorry. So it was more like this. We've got our horizontal line here at y equals 5. And we've got this line here. Okay, and this answer here was 1.5 and 5. And this answer here is going to be negative 5.5 and 5. Exact same questions as same answers rather, as when we did over here. And our graph looked like this. Okay, and this answer here was negative 5.5, and this one here was 1.5. Okay, here we looked for the zeros. Okay, here we found the zeros. here we found the x coordinates of the intersections. So our x values here were still the same, but we used a slightly different approach. Okay? So if you want to try question G using both methods, okay, or using even one method, I prefer the y1, y2. I don't have to do any messing around with moving anything over. I would enter 2x squared plus 3x and 5 minus x. So y equals 2x squared plus 3x and y 5 minus x it was. And when I do a graph, I've got two lines, one's linear, one's a parabola. Second, calculate number 5, the intersection point. Okay, right away I'm close to that one. That value there is 0.87, which would be 0.9. Okay, and we do the same thing. I'm going to find that other intersection point. Enter. Over to the right, enter. And that one there is negative 2.87, which is negative 2.9. So our two answers for that would be x is equal to negative 2.9 and x is equal to 0.9. Okay? So why don't you give that a try, and if you can figure out that would be great. Okay? Now, pause the video, and I'd like you to try to find the roots of these ones. Okay, I don't know why this says page 209 here, but I would like you to try to find the roots of these using your graphing calculator. Okay? Give the video a pause and go ahead and do that. Okay, so hopefully you had a chance to pause the video and try these on your own. But if you look at number 1, your answer should have been x equals 3 by entering that in your calculator. So what you want to do is look at this one, and you can also, we knew this was going to be x equals 3, at least we maybe would have recognized that, because of course if we look at this, this is a perfect square trinomial, which we've been looking at when we've been completing the square. So we know that could also be written as x minus 3 squared, okay, which would have been, of course, our function with the vertex of positive 3 and 0. Okay, so that's, of course, a parabola that's moved over to the right 3 and it hasn't moved up or down. So we have one particular answer where x is equal to 3. Okay, got the same thing written there. If you look at question 2, we've got y equals 2x squared plus x and y equals negative 2. That graph, there's no intersection, so of course the answer there is no solution. And our last example here, we've got two intersections. When we enter those y1, y2, and those are our two answers. X is negative 0.7 and x is equal to 1. So what we've got is we've got three scenarios, okay? Three scenarios. We can have a graph having 1, 0, such as this one, where that would be something like a vertex of 3, 0, okay? We can have an sorry, that would be the 1, and then 0, zeros, which would mean here there's no intersection. Okay, so therefore no solution. Okay, there's no answer there. Or we can have where it intersects twice, and we can have two answers. Okay, two answers. So 0, 1, or 2 answers. Okay. All right, let's look at the next one. And so this is probably sort of like a little bit of a problem-solving one, okay? This next one, it says, this next example, it says quadratic equations with two distinct real roots. So there's the manager of Jasmine's Fine Fashions is investigating the effect that raising or lowering dress prices has on the daily revenue from dress sales. The function r of x equals 100 plus 15x minus x squared gives the store's revenue R in dollars from dress sales, where X is the price change in dollars. What price change will result in no revenue? So if we look at the price change here, price change being X, we're looking to solve for X. We want to find X, where we would have no revenue. So therefore our revenue would equal to 0. So what we're basically being asked to do here is to find and solve a quadratic function, okay, where where y or r is 0, which is now then a quadratic equation. Okay, so to do this one, we could always do this algebraically, but this is the graphing calculator lesson, okay, and we're practicing using our calculator. So I'm going to plug this in my calculator. So 100 plus 15x minus x squared, or you could always put that in the other order, in descending order, and say it's negative x squared plus 15x plus 100, either way, okay? And when we do a graph, okay, right away I'm going to do a zoom fit. I definitely cannot see much. So what I can do here is I can do a zoom fit to kind of get a start, okay? And now we're looking for the x-intercepts, right? We're solving for x. I can see one of them right away, so I could find that 0. Okay, I can scroll over to the left, push enter, scroll to the right, push enter, and that value there is x is negative 5. If I want to see the other x-intercept, I'm going to have to change my window and move way over to the right. So I'm just going to change this 10 to, I don't know, maybe a 50. Let's just see if that works. Okay, it did. Okay, sometimes I go too slow, so sometimes I would try 20 and 30, but I'm just going to go 50 right away. It's okay if we go too far. Okay, so then again, I'm going to find, whoops, that that x-intercept using the 0 feature. Second function, calculate the 0. And I want to move my cursor left of the 0 and right of the 0. Oh, and it said no point. I think I may have touched the wrong thing. Let's find that 0. Left bound, enter, right bound, enter. There we go. And that x-intercept is 20. Okay, we're looking at the square, and the bottom there is 20. The little dot underneath is just the reference point, but it's the square that is the answer. So our 0 is 20. So our two answers there were x is equal to negative 5 and x is equal to 20. So what price change will result in no revenue? Either a drop in price of $5 or an increase of $20 will result in no revenue for the shop. Okay, the fine fashion dress shop. Okay, I'm just gonna, in the interest of time, skip this last question for now, but hopefully that is a little bit of a help for how to use our graphing calculator to solve for roots of an equation. Okay, good luck. Make sure you look at the printout and have a look at which questions you should do for the lesson 1 assignment.